Hi everyone. So every AI model that you have talked to writes the same way. One word, then the next, in order. And it never goes back. In June 2026, Google released a model that breaks that rule completely. It's called DiffusionGemma. And instead of just reading about it, I built a small demo to test it myself. Let me show you what actually makes it different. So here is how the normal model, like Google's own regular Gemma model, writes text. Think of an old typewriter. Once a letter hits the page, it's permanent. The model predicts one word, locks it in, then uses everything written so far to predict the next one. This process is called as autoregressive generation, and every word depends on every word before it. It's also why long answers can feel a little slow. The model is doing this one word at a time, however many hundred words you asked for. So imagine this sentence: the cat sat on. So the next word, any regular model, any regular LLM, just like Gemma 4, would look at all the words before and then predict the next word and write it. So it's typing one word at a time. What Diffusion Gemma does instead is, let's see it. So Diffusion Gemma does something completely different. Picture a block of 256 word slot, all filled with random noises. Diffusion Gemma looks at the entire block at once, decide which word looks wrong, redoes just those over and over until the whole thing settles into a readable text. This is the same underlying idea behind every AI image generation like Stable Diffusion, which starts from random static and gradually clears into a picture. Diffusion Gemma does that with text instead of pixels. Every word in that block can see every other word at the same time. It isn't writing in order, it's refining the whole block together in up to 48 passes until it's done. Now, why it can be faster and the honest trade off here? Here is why this can actually be faster. Normal one word at a time generation is memory bound. For every single word, the model has to pull its entire set of weight through the GPU, do a small amount of math, then repeat. Diffusion flips that, pulling those same weights through memory once and using them on a 256 word at once turns it into a compute bound task, which is exactly what GPUs are built to be fast at. The real numbers, Google report over 1000 tokens per second. That's incredibly fast on a single NVIDIA H100, roughly a 4x speed up. But obviously, it's not all upside though. Diffusion Gemma trades some accuracy for that speed, and it's a labeled experimental so far. Google itself still recommends regular Gemma 4 when quality matters. So, to actually see this instead of just describing it, I build a small live demo. So, I'll paste a paragraph here with planted mistake, and both model Gemma 4 and Diffusion Gemma will try to fix it at the same time. Now let's see it in action. So I pasted this paragraph, and as you can see, there are three planted mistakes. The Eiffel Tower is in London, built in 1901 and 500-meter tall. Now these are the three planted mistakes I put in this paragraph. Now when I hit fix with both model, first Gemma 4, let's see how Gemma 4 fixes it and how it gives the response. I'll fast forward it a little. Now watch Gemma 4 on the left. It writes the fixed in order, one word after another. So you see, it is writing the fix one word after another. Now look at Diffusion Gemma on the right. The whole block appears together at a very fast speed. The whole block appears together and sharpens its in place. So the point behind this demo was to basically explore how different these two models are. And as you could see, the Gemma 4, like any other regular autoregressive model, prints one word at a time, one token at a time, and then corrected all the mistake, but one word at a time. And once corrected, it can't go back. Whereas in Diffusion Gemma, you saw the entire block appear at once with the corrected mistake. Now, obviously, behind the scene, it would have generated all 256 words, then checked which one is wrong, right? and after a few passes it would have displayed the entire paragraph. So this was the whole concept of this demo, to understand the difference practically. If you want to get deeper into this and how this actually works, I've got the full write-up linked below, and there is a full blog about it that I wrote, and you can read about it. Thank you so much.